Welcome to the Ontario High School video podcast regarding the mole and mole conversions. And the scope of this podcast will just talk about the mole, uh, Avogadro's number, and how it relates to the mass in grams that we find on our periodic tables, what we'll refer to as the molar mass. So conversions between molar mass and moles and Avogadro's number, those will all be covered in this podcast. So, welcome. The mole is a unit used by chemists to represent a large number of particles. In this case, it's 6.02 times 10 to the 23rd particles. An everyday practical analogy is that we represent 12 eggs with a unit called the dozen. In chemistry, we're going to represent 6.02 times 10 to the 23rd particles by a quantity of 1 mole. Now, the particles in chemistry that we're concerned with are atoms, molecules, and formula units. Atoms of discrete elements, such as I have X number of iron atoms. Molecules are compounds that form from nonmetals, 2 or more nonmetals together, bonded covalently, and so those form molecules. And formula units are what we use to represent ionic compounds. And if you remember, ionic compounds are compounds that contain metals, and the bonding between particles is ionic, meaning that the particles form cations and anions and have an electrostatic attraction between them rather than sharing electrons like non-ionic compounds. The relationship between the mole and the mass in grams is very important in chemistry. It's impossible for us to count atoms individually. There's just not enough time available to us to do that. So we represent large numbers of particles by this unit called the moles, and then we relate them to the mass in grams. So a statement that we're going to make is this, that 1 mole of particles is equal to the mass in grams of 6.02 times 10 to the 23rd of the relevant particles. Now the mass of 1 mole of particles, and we will refer to this as both molar mass or gram formula mass, is determined by using the information that's found on your periodic table. Here's a look at some information that would be found on most periodic tables. We have 2 elements represented here, calcium, which is represented by the symbol Ca, and chlorine, which is represented by the symbol Cl. Now there are 2 round, smaller numbers for calcium 20, for chlorine 17. That's known as the atomic number, and it represents the number of protons in the nucleus of the atom. And one of the things that we talked about is that the number of protons in the atom determines its identity. Each element has a unique number of protons. Sometimes they can share the same number of neutrons depending on different isotopes that they have, but all atoms, all elements have a unique number of protons. And that's what that smaller whole number in this information represents. Now there's also a larger number on the periodic table, and normally this number is a decimal number because it represents an average of all the naturally occurring isotopes together. So we can see here for calcium 40.0788, and this is known as the atomic mass or average atomic mass. And one of the unique things about this is that it's shown without a unit. And you know from chemistry class that almost all numbers in science have units with them. It's very important to have the proper units. But for calcium, the atomic mass is expressed as 40.0788. For chlorine, its average atomic mass is 35.4527. And the reason no unit is shown here is that this is the mass of one, for instance, 1 calcium atom would be 40.0788 atomic mass units. And we'll talk about what an atomic mass unit is soon. Chlorine, the mass of 1 chlorine atom would be 35.4527 atomic mass units. When we talk about 1 mole of calcium atoms, which is 6.02 times 10 to the 23rd calcium atoms, the mass would be 40.0788 grams, and the mass of 1 mole of chlorine would be 35.4527 grams. The unit we apply to the average atomic mass depends on whether we're talking about an individual atom or a mole of atoms. The first chemistry mass unit that we want to talk about is the atomic mass unit. We have it symbolized here as an AMU. You will also see it in some textbooks as just U. And individual particles, such as atoms, molecules, or formula units, are measured in AMU. And the definition of an AMU is actually 1/12 the mass of a carbon-12 atom. Carbon-12 is a particular isotope of carbon, and it's equivalent or equal to 1.66 times 10 to the negative 24th grams. Now that number, 1.66 times 10 to the negative 24th grams, is not an easy number to work with, so for chemists it was easier to just declare that 1 AMU. So one calcium atom has a mass of 40.078 AMU, one chlorine atom has a mass of 35.4527 atomic mass units. The mass unit in chemistry that we're most familiar with and will use most often, especially in terms of laboratory work, is the gram. And again, when we're talking about 1 atom of calcium, it's 40.0788 atomic mass units. When we're talking about 1 mole of calcium atoms, which is the same as 6.02 times 10 to the 23rd calcium atoms, that would have a mass of 40.078 grams. And 1 mole of chlorine atoms would have a mass of 35.4527 grams. Well, here's an application of using formula masses and molar masses. We want to determine the formula mass and the molar mass of calcium chloride, CaCl2. Now, formula mass, we're going to use at Ontario High School anyway, is referring to one formula unit in terms of calcium chloride, because calcium is a metal. This is an ionic compound, so we're not going to call CaCl2 a molecule, but we will refer to it as a formula unit. So on our formula mass, we're going to take 1 calcium, which is 40.078 atomic mass units, and add it to 2 chlorine. So we'll multiply the 35.4527 atomic mass units of chlorine by 2. We add those together. We have 40.08 plus 70.90, and we get a formula mass of 110.98 atomic mass units. Now, one of the things that you'll notice is that I rounded this to the nearest hundredth of an atomic mass unit. And if you're from another school, your teacher will have probably a policy regarding what atomic masses in terms of rounding, how far you should go out, and make sure that you follow your teacher's instructions on that. But here at Ontario, going to the nearest hundredth is adequate precision for us. We've determined the formula mass of calcium chloride. We're going to go ahead and determine now the molar mass. And again, this would be if I had 6.02 times 10 to the 23rd formula units of calcium chloride, which we'll refer to as 1 mole of calcium chloride, what would its mass be? And as you look at this problem-solving process, you'll notice it's the same as solving for formula mass, except instead of using AMU, or atomic mass units, as the mass unit, we'll use grams. So 1 mole of calcium is 40.078 grams. We're going to add that to the mass of 2 moles of chlorine, which would be 2 times 35.4527 grams. So 40.08 plus 70.90 grams would equal a molar mass, or gram formula mass, of 110.98 grams. Well, let's do some sample calculations together. Here we're going to determine the formula and molar masses of the following compounds. The first one is C3H7OH. The second one is Cu3, PO4 in parentheses 2, which is also known as copper 2 phosphate. And then finally N2O5, which is dinitrogen pentoxide. The C3H7OH is a 3-carbon alcohol, And depending on what the oxygen is bonded to in terms of which carbon is bonded to, it can either be called N-propanol or 2-propanol. For C3H7OH, we have 3 carbons, so we'll do the formula mass first. So we'll take 3 times 12 atomic mass units, gives us 36 atomic mass units of carbon. There are 8 hydrogens. You'll notice that this is C3H7, and then there's also a lone hydrogen on the end of this, so 8 hydrogens total. 8 times 1 atomic mass unit gives us a total of 8 atomic mass units of hydrogen, and then 1 oxygen is 1 times 16 atomic mass units, which gives us 16 atomic mass units of oxygen in this compound. We add those together, it gives us a total of 60 atomic mass units. So the formula mass per molecule is 60 atomic mass units. The molar mass, I would just change from the unit from atomic mass units to grams. So the molar mass or gram formula mass of C3H7OH is 60 grams per mole. Next, we'll find the formula and molar masses of copper 2 phosphate. Here we have 3 coppers, and again we'll do formula mass first. So we have 3 times 63.546 atomic mass units would give us 190.64 atomic mass units. Because this phosphate ion, there's more than one polyatomic ion, we put it in parentheses with the subscript 2 outside it to show that there are 2 of these. When you go to count the number of phosphorus atoms in this compound, you have to multiply the subscript on the phosphorus, which isn't shown because it's 1 and we don't show subscripts of 1, but we would multiply that by the subscript 2 outside the parentheses. So we have 2 phosphorus atoms, and that would be 2 times 31 atomic mass units, which gives us a total of 62 atomic mass units. And then we do the same thing for the oxygen. The subscript on oxygen and the phosphate ion is 4, and then we multiply 4 by the subscript outside the parentheses to show that there are 8 oxygens. So 8 times 16 atomic mass units gives us a total of 128 atomic mass units of oxygen. We add those together for our formula mass. So per formula unit, copper 2 phosphate has a mass of 380.64 atomic mass units. Its molar mass has the same number, 380.64, but the units would be grams per mole rather than AMU. So the molar mass is 380.64 grams. Next, let's look at dinitrogen pentoxide, and we're going to look at finding molar mass of this first. And if you have 1 mole of dinitrogen pentoxide, you'll have 2 moles of nitrogen. So we'll take 2 times 14 grams per mole of nitrogen would give us 28 grams of nitrogen in this compound. You would have 5 moles of oxygen for every mole of N2O5. So we'll take 5 times 16 grams per mole, which would give us a total of 80 grams of oxygen. We add the 28 and 80 together, and that gives us 108 grams per mole. And that's the molar mass, 108 grams per mole. Now the formula mass per molecule would be 108 atomic mass units. So we just did the molar mass first and then applied the atomic mass unit rather than grams to find the formula mass. We've come to the end of part 1 of the video podcast series that deals with how to determine the molar mass of compounds and then convert to moles or to the number of atoms or molecules. I want to leave you with a quote from Niccolo Machiavelli. Now, you've heard the name Machiavelli oftentimes associated with rather sinister things, but not everything he said was sinister. So I want to quote one that is not. Entrepreneurs are simply those who understand that there is little difference between obstacle and opportunity and are able to turn both to their advantage. Stay tuned for part 2.